Today we are looking at the Lesson 3 notes in the Unit 1 notes packet, so please follow along. This lesson covers clearing fractions and finding slope. So it's a continuation of Lesson 2, solving equations, and then kind of introducing the second half of the unit, which is all about graph. So what is the easiest way to get rid of fractions in an equation? Instead of going straight to opposite operations, we can kind of clear the fractions all at once and then solve like normal from there. So the easiest way to get rid of fractions in an equation is to multiply each term by the least common denominator, or the least common multiple of the denominators. So what we're going to do for each of these questions is I will take a look at the denominator specifically, and we will decide what to multiply everything by to clear those fractions, and then solve using the steps that we discussed yesterday. So for the first one, we've got a 4 and a 3 in the denominator. That looks like our least common multiple will be 12. So for both sides of the equation, or for both terms, I'm multiplying by 12. This gives me 9t is equal to 8. Once I have the fractions cleared, then we solve just like normal. I need to divide both sides by 9. So we get that t equals 8 over 9. For the second one, it looks like we've got 3 and 4 in the denominator again, but we've got lots more terms this time. So as I multiply everything by 12, it looks like there are 4 terms, or 4 different multiplications that will need to happen here. So we have 12m plus 8 equals 3m minus 12. Now we'll combine our like terms with addition and subtraction. I might subtract 3m first. So we have 9m plus 8 equals negative 12. Subtract 8 from both sides. And then divide by 9. Okay. For our third question, now we have some simplification or distributive property that needs to happen first before we clear those fractions. I need to see each term individually before I can decide what I'm going to multiply by. It also makes sure that maybe this distributive property step might clear the fractions in and of itself. So if I were to multiply here into the parentheses, I might not have a fraction after that, so it's worth trying to simplify first, and then we can use clearing fractions after that. So this becomes 2x. That fraction is cleared, but then we have to add 2/3. So it looks like my least common denominator, or common multiple in the denominator, is 3. So we'll multiply everything by 3 here. That makes it 6x plus 2 equals 15. Don't forget, even on both sides of the equation, we got to multiply everything by that 3. can subtract 2 from both sides. Combine those like terms, opposite operations, and then divide by 6. Looking so far at these answers here with crazy fractions would have been much harder to solve, either by hand or even with a calculator using those opposite operations. But because I cleared the fractions, I can do these steps real quickly, and I do get a messy answer, but it was much easier to solve because I did that first step of clearing fractions. All right, 2 more here. This one, it looks like we have both a 3 and a 2 in the denominator. So least common multiple there might be 6. Distribute to all 4 terms. This is 2 plus 12m equals 6m minus 9. Add 9 to the other side, or subtract 6 to the other side. Again, the order doesn't matter. Which like terms we combine first. Generally, I use variables first, so I might do that here. This is 6m, and then we'll subtract 2 from both sides to get m isolated, and divide by 6. And lastly, it looks like we've got some more distributive property to take care of first. Now there is 2 different denominators, but they're the same number. So they're both 4, which means I can take care of clearing these fractions by multiplying the entire equation by 4. It will clear both of them. So this becomes 6x plus 3 equals 8. I'll subtract 3 from both sides and divide by 6. I encourage you to pause this video now if there were any of those that you feel like you need more clarification on, or any of those steps looked a little funky. Star them in your notes. Make sure you think about sending your teacher an email to ask about the order of things that were done, or if there's anything, maybe I made a typo in this video. Make sure that you're thinking about those questions that you have so that you can ask your teacher about them later. The second part of these notes will be about finding slope. So to recall, the topic of slope, what we're looking at is the steepness of the graph of a linear equation. We're referring to rise over run, or the change in y over the change in x. So all considered definitions of slope. We are going to be able to find slope either from a graph, so looking visually at that rise over run, from a table. If you have a list of x's and y's in a table, can you tell how each of those x's is changing and how each of those y's are changing? And then write that as a slope. We can also look at the slope between 2 points. And then from an equation, all of our different forms of linear equations, which part of those equations give us the slope. So that's kind of what we're looking at, refreshing our memory on from previous math classes. So here are 4 types of slope. If we are increasing from left to right, this is a positive slope. If we are not increasing or decreasing from left to right, then that is a zero slope. If it is flat. If we are decreasing then from left to right, then now this is a negative slope. He is going down. And then we've got our guy in the middle here, straight up and down. He's falling or something like that. This is considered undefined slope. I also have shared with some of my classes and teaching this in the past, and maybe you find this on Google if you search different types of slope. But I always enjoy looking at slope guy and drawing this. So this is my way that I usually remember my slope. So I have positive slope here. His eyebrow is increasing from left to right. I have negative slope for this eye. His eyebrow is decreasing. I have undefined slope for his nose, straight up and down. And then zero slope for his mouth being straight across. So that could be another way to kind of remember which type of slope is which. So let's go through each of these methods of finding slope. If we're looking at a graph, this is where I can visually see the rise over run on a graph. So how much am I going up and over from one point to the next? So starting here on the left, looks like in order to get to the other point, I have to increase 4. So that's positive 4 for the rise. And then we run, again in the positive direction, 5 units. So we've got 4 over 5 for that slope. And the y's on top. Y's matches with rise. Also rhymes with rise. And then x's on the bottom is our run. If we're finding the slope of the line that goes through 2 points and we can't visually see the graph, then we just need to calculate those pieces. So it always helps me to go ahead and label. This is my first x and y coordinate. This is my second x and y coordinate. So that when I try and plug this in, I know exactly which numbers to grab. Here it looks like we're taking the 16 minus the 8 over negative 3 minus 1. Gives me 8 over negative 4 or negative 2 for the slope. You're also welcome to leave that as negative 2 over 1. If we're thinking about rise over run, it's helpful to leave things as fractions. But you're always more than welcome to simplify those fractions at any time. What if we were given equations? How do I find the slope from just looking at an equation? Well, it depends on what form the equation is in slope-intercept form, that is our y equals mx plus b form. Deals with both the slope and the y-intercept. So in this case, I am just looking for that m. This is my slope. So we find our x term in the equation that we're given, and that number in front of the x, or being multiplied times the x, is our m. So in this case, the slope is 3/8. Remember not to include the x in that slope. Rise over run is just a value, no variables. So 3/8. For standard form, we have 2 options. If you are the type of person that loves formulas, is really good at memorizing things, then in standard form, which is ax plus by equals c, the slope is always going to end up being negative a over positive b. So taking kind of a formula approach to finding the slope here, we can find that this is now negative 9 over 3, or in other words, 3. The other option is to go ahead and solve for slope-intercept form. So I could get y by itself. By adding 9x to the other side. And then dividing everything by 3. Make sure you divide all parts. That means in order to get y by itself, I'm dividing both the 9x and the 10 by 3. And so now I can see that the number in front of x, or that's being multiplied times x, is 3. Okay, this last page of lesson 3 says, now you try. So I am going to pause and end the video here now. I do want you guys to try and fill out this page, going back through each of these types of finding slope, and do that yourself. I will be uploading a completed version of these notes, including this page. So if you need to go in and check your answers, or if you get stuck on any of them, you're welcome to go to that completed notes PDF and find my work there. If you have any questions, again, feel free to email your teacher. They can help you out and make sure that you remember all of this stuff going forward so that the rest of this unit is a breeze.